A monomial is either a number, a variable, or a product of a number and one or more variables. So let's talk about this. So we said prefix, mono means one. So a monomial could be just a number. So for example, like the number 3. That's a monomial, just a number, right? It could be just a variable, like x or y or whatever. Or it could be a product. We know product means what in math? The answer to a multiplication, right? So a product of number and one or more variables. So also like 3xy squared, that's also a monomial. It's one term, okay? So it could be a number, a variable, or a product of number and one or more variables. These are all different monomials, right? For example, this would not be a monomial. Of course, this would not be a monomial because it contains addition. It's actually two monomials, which has a different name, okay? A monomial, number, variable, or product of number or one or more variables, okay? A constant is a monomial that's just a real number. So which of these is a constant? 3x or 3xy squared? Yeah, just 3. It's just a number, okay? A constant. Constant means it doesn't change, right? That's a number that doesn't change. 3 is 3 no matter what x is, no matter what y is, no matter what any variable is. We call those constants. And then coefficient. Coefficient is the number that's in front of the variable that's being multiplied. That's a product of the variables, right? So, in this monomial, the coefficient is obviously 3, right? It's the number being multiplied to the variables, right? If I gave you this is a monomial, the coefficient would be -4. It's the number in front that's being multiplied to the variables. Which brings us to what a polynomial is it can be just a monomial or the sum or difference, so adding or subtracting of monomials. So poly means many, right? So for example, 3x plus y, we would say that's a polynomial because it's two monomials being added together. Actually, it's a specific type of polynomial. It's called a binomial, just like bicycle. Bi means two. Binomial means it's the addition or subtraction of two monomials. This would be an example of a binomial, right? Two monomials being added together, or they could be being subtracted together. Then, of course, a trinomial, okay, is the addition or subtraction of three monomials. So let's say you have this. That's a trinomial, right? It's three separate monomials that are being added or subtracted together, right? 1, 2, 3, separated by plus and minus signs. Trinomial. Anything other than a monomial, binomial, or trinomial has no special name. We just call it a polynomial. Poly means many, right? So these are types of polynomials, specific types of polynomials. The reason they have special names is because we use them a lot more often. We use binomials, trinomials, and monomials a lot. Yeah. Anything bigger, so for example, this has 4 monomials, right? 4 terms, just called a polynomial. Okay? So what we're going to work on today is adding and subtracting polynomials. Okay? This can include monomials, binomials, and trinomials. Here is, you've heard this before, like terms. These are monomials that have the same variables raised to the same exponents. Here's the main key I want you to remember from today. You can only add or subtract like terms. You cannot add or subtract things that do not have the same variables raised to the same exponents. You can multiply them, that's what we just did last week, right? You can divide them, that's what we did just last week. But in order to add or subtract, they have to be like terms. Right? Let's go over some common examples of possible like terms. Are these two monomials like terms? No. They're close, but they're not. Why are they not like terms?
They're not raised to the same.
Exactly. Not raised to the same power. This has power of 1. This has power of 2. Right? Are these two monomials like terms?
No y.
I can see why you'd think, but it's close. I would say they're not, because this is y to the first, x to the second. This is y to the second, x to the first. Right? I would say these are not like terms. So if I asked you to add these, you could not do anything. You can't go any further, right? But if I gave you something like this, those are like terms, and you can add those together. 3x squared y plus 4x squared y would be 7x squared y, right? You can add those together because they're the same variables to to the same exponents, okay? You can only add or subtract like terms, so that's what we're going to practice today. So, let's look at an example. Simplify this expression. It says all answers must be written in descending order, and this means descending order of exponent. That's actually called the degree, which we'll talk about some other time. But basically here I have a trinomial being added to another trinomial, and I want to simplify all of this. So since we're adding these two things, I have to look for like terms. And what I personally do is I underline my like terms the same way, just to make sure I get them all. So 7y squared, I look, obviously I can't add that to the 2y, it's not a like term. I can't take minus 3. I'm going to plus this trinomial. Of course, the like term there is 5y squareds, right? So if you have 7y squareds, and we need to add positive 5y squareds, that of course gives us 12y squareds. How about the 2y? What's my like term with it?
Negative 4y.
Yep, the minus 4y, the negative 4y, right? So this says you take 2y's and you add negative 4y's. How many y's are you going to have? You have 2 and you add negative 4. Exactly, right? Negative 2y's. And then I have negative 3, and it says add, its like term, that's the constant, is 2. Well, that's just negative 3 plus 2, negative 1. I look at my answer and I say, okay, have I combined everything? Do I have any more like terms? And I don't. So my final answer would be that trinomial, 12y squared minus 2y minus 1. Okay? And again, some people like boxing them certain ways, like they'll box this like term, they'll circle this like term, they'll put a triangle around this one. I've seen that before, right? I just go through and underline them differently to make sure I accounted for all of them. Okay? And there's my answer. Take 2y squared plus 8 plus y minus 8 plus 3y minus 4 is y squared plus 2. I'll give you a minute or two and then we'll walk through it. All right, 2y squared plus negative 4y squared. Remember to always take the sign that's in front of it. I get negative 2y squared. Positive y plus 3y. 1y plus 3y is 4y. And negative 8 plus 2 is negative 6. No more like terms. There's combined. Now, what would you have done if there was pretend there was a 3y to the third here, and it had no other like terms? What would you have done with it?
Leave it as.
Yeah, just leave it as 3y to the third and put it as part of your answer, right? If it has no other like terms. It just so happens that all three of these had 3 like terms over there. That doesn't always happen, though. Okay? All right, now let's talk about subtraction. It's the same thing, subtraction. However, you need to be a little bit more careful because this minus sign applies to all terms in this set of parentheses. It's minus this, and minus this. Okay? Some people can think of it as distributing a negative 1. If you wanted to do that, you could go through and distribute the negative 1 there. Okay? But let's just go through this example, but we have to be careful of keeping track of that minus sign. All right, so I have 6y squareds, and it has a like term right here. So this is 6y squared minus positive 2y squared. So that's just 6 minus 2, so that's going to leave me with 4y squared, right? Now it says I have 8y to the fourth minus positive 9y to the fourth. Again, this minus applies to everything in here, right? So 8 minus 9 gives me negative 1y to the fourth. Then I have negative 5y. You have to be careful here because it's negative 5 minus negative 7y. Right? That minus is going to become plus. So it's negative 5y plus 7y. Give me positive 2y, right? That would be my final answer because I have no more like terms. Okay? So minus is the same thing. You just have to be careful that this minus applies to every term in that set of parentheses. All right, so looking at our like terms, 3ax, take away like term there. So it's 3x minus 8ax. So that's going to become plus. So 3 plus 8, I'm going to get 11ax there. Now, this is a weird way to write it, why it says plus negative 5x. It should just say minus 5x, but it's the same thing, right? So negative 5x minus 4x. Negative 5 minus 4, I get negative 9x. And negative 3a, but it's minus 6a. Well, it's negative 3, subtract 6 more. Right? I get negative 9a, right? That takes care of everything, no more like terms. So again, even if you didn't write it in that order, as long as you have a minus 9x, a minus 9a, and a positive 11ax, that's what we're looking for.